So we are talking about the interactions in the universe and conservation laws. With this physical world chapter will be concluded today. So from Monday, we'll learn the importance of measurement, and we'll try to understand various mathematical tools which are very frequently used in solving various physics concepts and problems. So these are the next week syllabus is the measurement and the mathematical tools. So now we are going to conclude this physical world. So there are different interactions in the universe, starting from Said Canard, who suggested the gravitational interaction, followed by Sir Isaac Newton, who first spoke about the gravitational interaction between Earth and the objects, which is known as terrestrial interaction. Later, he extended his argument between sun and planets, then between galaxies. I told you other day when I was explaining it, the range of the gravitational interaction was between the nucleus and electron with mass range of 10 to the power of minus 27 kilograms to 10 to the power of minus 31 kilograms to the galaxies. So that is mass range of galaxies will be in the order of 10 to the power of 45 kilograms. So that's why we can say Newton could unify the terrestrial gravitation with the universal gravitation. Then the unification of interactions was it has been happening regularly. There are other forces like electromagnetic force. Earlier, in the beginning, when we were doing the intermediate in 1977-79, and when I started teaching plus two in 85, and even till 96, we were doing electrical interaction and magnetic interaction separately. Now, those two interactions were unified as electromagnetic interactions. Then we also have the nuclear interactions. There are two types of nuclear interactions based on the nucleons we are considering. One is the weak nuclear interaction. Second one is the strong nuclear interaction. Even these two are unified. So finally, this is called unification theory. So we called grand unification theory, GUTs. I'm going to show you the slides. So where all the interactions will be unified into a single interaction. So now I'll switch over to whiteboard. So I referred about this is I think 8 interactions. So we have the first one is gravitational interaction, which can be of two types. One is terrestrial, second one is astronomical. So it acts between any pair of masses with mass range of 10 to the power of minus 31 kilograms to 10 to the power of 45 kilograms. So these two are unified as the gravitational interaction. It's called GI. GI means gravitational interaction. Then we have Oersted. This was of course done by Newton. Oersted, Faraday, Maxwell. They could unify the electrical interactions and the magnetic interactions, which were now called as electromagnetic interactions. electromagnetic interactions. Of course, this unification of electrical and magnetic interactions was done, majority contribution was by Maxwell. Then we have single, for third one, nuclear weak interactions. Fourth one is nuclear strong interactions. Nuclear weak interactions and nuclear strong interactions. For this also, scientists like physicists like Enrico Fermi, Pauli, and many others worked a lot. And finally, all these interactions were now combined with the help of grand unification theory. Grand unification theory. It is also called as theory of everything. So, and which resulted a single interaction called universal interaction. Grand unification theory or theory of everything, this is only called as universal interaction. Now, starting from Fg is to F electromagnetic is to weak nuclear interaction is to strong nuclear interaction, we can write it as, yes, the ratio can be shown like this: 1 is to 10 square is to 10 to the power of 9 is to 10 to the power of 38. So this is the ratio. What do you mean by this? Very important point you must remember. Questions are appearing even based on this physical world. Many of you may be feeling that Sir is killing time by telling some stories. No, absolutely not. Nothing nonsense will come from us. With this expertise and international exposure, with 36 years experience, what all we present on the screen will be useful in one exam or the other. So here, this relation between the various interactions can be shown with this ratio. The gravitational interaction is to electromagnetic interaction, is to weak nuclear interaction, is to strong nuclear interaction, will have a ratio of 1 is to 10 square, is to 10 to the power of 9, is to 10 to the power of 38. What do you mean by this? The strong nuclear interaction is 10 to the power of 38 times stronger than the gravitational interaction. I will be presenting separately. So the strong nuclear interaction will be in the order of 10 to the power of 38 times more than the gravitational interaction. And the weak nuclear interaction will be 10 to the power of 9 times stronger than the gravitational interaction. The electromagnetic interaction will be 10 square times the gravitational interaction. So the weakest interaction among these 4 possible interactions among various particles irrespective of their masses is the gravitational, and the strongest is the strong nuclear interaction. Then the last part of this topic is the conservation laws. Conservation laws. Conserve means remains constant. It won't change. Invariant. The meaning of conservation is invariant, and the statement will come like this. For any physical quantity, the common statement is the physical quantity remains unchanged during all possible physical phenomena. I'll just present it in brief. The physical quantity will remain unchanged during all physical phenomena. General statement of the conservation law. The physical quantity can be energy, it can be mass, it can be momentum, it can be angular momentum. So these are all the conserved quantities. And charge, electric charge. You might have heard them. Law of conservation of energy. Energy in the universe is constant, can neither be created nor be destroyed, but can only be exchanged. The mass is always conserved. Mass is never destroyed. Momentum. In the absence of external forces, the total linear momentum vector of a system remains constant. In the absence of external torque, the total angular momentum of a system in rotating frame will be conserved. Last, charge can neither be created nor be destroyed. It can only be exchanged between the bodies. So these are all the various parameters whose conservation laws we'll be learning one chapter after the other chapter. Then we have another principle called, same thing is put as invariance principle. Principle of invariance. What will it state? All laws of nature will not change even if some physical conditions are changing. So the laws of nature, what I earlier mentioned, will remain same even with the changing physical conditions. So this is called principle of invariance, and we'll be applying them in discussing various parameters and chapters. Of course, Newton could speak about the law of conservation of energy and mass. Einstein related this mass energy conservation. I gave the formula E is equal to mc square. So with this, the physical world chapter is concluded. Now I'll be presenting you a few important PPTs. You can say it's a review of what all we have studied in this chapter. Please go through that. Yes. Are you able to see? Are you able to see the PPT? Yes?
No, sir.
Rakesh, you are
No,
not
sir.
able to see?
No, sir.
Okay, I'll try once.
Now we can see, sir.
Now that physical world PPT is seen there. Are you able to see?
Yes, sir. Yes, sir.
Yes,
Now
sir.
we can see, sir.
Good. So if you are interested, I will share them, because what all I'm
Post
showing
in group,
here
sir.
is the cream of our discussion from the beginning in this week. So questions are being asked.
Sir, post this in group, sir.
Pardon?
Post this in our group, sir.
Yeah, I'll do it if you are interested. Otherwise,
Okay, sir.
it's waste. Okay, I'll do
Okay.
it. Fine. So we have the physical world. This is the chapter, first chapter in NCERT syllabus. My focus will be only JEE syllabus. I don't focus on state board syllabi. I don't know. I think Telangana and Andhra are following NCERT only. Which book you have studied last year? Sorry, which book is prescribed for you? You're doing
Eight, sir.
NCERT only? Yeah, let me know by Monday, okay? So
State
this is the
syllabus,
first
sir.
slide. Physics deals with the study of the basic laws of nature and their manifestation in different phenomena. Different phenomena means it may be related to the forces, It may be related to the impact of forces on a system. It may be related to the impact of the energy and the conservations, and it may be related to the rotating frame of reference. It may be referring to the planets. It may be referring to the thermal physics. It may be referring to the optics, anything. They're all called the different phenomena which we are going to learn. So it deals with the study of basic laws of nature, their manifestation, different phenomenon, and the basic laws of physics are universal. Yeah. I will quote one example. I should not, but I am telling. Last year for JEE exam, we gave one question where the question was related to universal gas constant. Just purposefully, I wanted to check the conceptual ability of the students. I gave the molecular weights of oxygen and nitrogen, 16 and 14. And I told you, the question was, what is the ratio of specific gas constants of these two gases? Students confused, and they put 1:1, assuming that universal gas constant is same. So the students were not knowing, they were not able to identify the difference between the universal gas constant and specific gas constant. I should not say this. One physics lecturer who handled one batch came to me and said, "Sir, you have to correct the key." I said, "Why?" The correct key is 1:1, whereas you give some 14:16. So 7:8, you gave the correct key answer, whereas it should be 1:1. Then I referred, specific gas constant is different, universal gas constant is different. So once you say universal, it is constant for oxygen gas, hydrogen gas, helium gas, neon gas, nitrogen gas. No difference. So that's what you mean by universal. So laws of physics are applied universally and between various ranges. So this is the first slide. Then see the second one. Physics deals with the, yeah, I think this is finished. Yeah, physics, technology, and society. We had a detailed discussion yesterday. I told you the pure physics will give you basic laws and relations. Applied physics transforms all these concepts and unifies all these concepts and mathematical relations, which then yield technology, and the domination of technology, the influence of technology on our society, nobody can explain. Starting from the moment at which you get up from the bed till you go to sleep, yes, the technology is dominating our lives. So without technology, you cannot imagine society now. Just science, technology, and society have strong relationships among one on other. Science is the mother of technology. I mean, I told you this, physics mostly. Even chemistry influence is there. All these drugs and pesticides, manures, they're all the products of technology of the chemistry. Similarly, the molecular biology and then genome coding, all these things are the technological phase of biology. So science is the mother of technology, and both of them are the reasons for the creation and development of society. Next point, science and technology issues are actually discussed worldwide today. Progress in this had led to produce ability to integrate different types of physical products. But mostly, as far as health field is concerned, medical field is concerned, still they are struggling with uncertainty, because somebody is doing research on the diseases and drugs, and doctors are treating the patients. So there is no coordination between them. See the worst case of this COVID. Doctors were advocating first to give plasma therapy, remdesivir. Now they say plasma therapy is not correct. Remdesivir also they stopped using. People were buying with one vial. They were buying with a money amount of around 35 to 40,000 rupees. A COVID patient, once he goes to hospital, the bill was like anything. S.P. Balasubramaniam singer, the bill was around 1 crore. Chennai hospital, with the intervention of Vice President Venkaiah Naidu and Tamil Nadu Chief Secretary, they brought it down to 50,000. And there were rumors that the hospital people denied to give his dead body also. Last July or August, I think. Yeah. So this is where but the medical field is lagging to coordinate between the medical technology and the physicians or surgeons. Yeah, that is to be improved in future. Next, Anandaya is doing a better work than our doctors with this. He was very confident. He was very certain. People in dying stage are going to him and getting recovered. So there is some gap between the technological phase and the applied phase of medical field. Yeah, things will improve. Nothing will happen abruptly. It's a time process. Then next point is physics is a basic discipline in the category of natural sciences. Means it is a part and parcel of natural sciences, which also includes other disciplines like chemistry and biology. Yes, Brownian movement in biology can be explained only with the help of physics. The rise of water from the roots to the branches can be explained with the surface tension phenomenon of physics. Similarly, in chemistry, the structure of atom, occurrence of spectral series, energy exchanges, all these things can be understood with the physics principles. So, physics influence is there on chemistry and biology. The word physics comes from, is a natural thing, Greek word meaning nature. Physics means nature. Then, so these are all the different physicists with their basic country of origin and their inventions. In fact, I wanted to add Saint Canard, Subramanian Talapade, um, Bhaskara, Bhaskaracharya, etc., etc. Aryabhata, Varahamihira, Susrut also should come in this table. I hope it comes in a very near future because they are the pioneers of different researchers in various fields. Yeah, I'll share this anyhow, of course. And these are the same table continue. And this is technology and the basic scientific principle. For example, steam engine, laws of thermodynamics, mass energy conservation, nuclear reactor, controlled nuclear fission, radio and television, generation, propagation and detection of electromagnetic waves. Like that, this is the technological product and the basic scientific principle involved in it. It is there in NCERT textbook also. I just put it in the form of a table. So next, what I refer now, fundamental forces. The four fundamental forces in nature are gravitational force, electromagnetic force, weak nuclear force, strong nuclear force, and even referred about this unification theory. Then the nature of physical laws. This is conservation. The physical quantities that remain unchanged in a process are called conserved quantities. There is a small typing mistake, conversed. It's conserved. So conservation laws have deep, what all I explained, I put it in the form of slides. So conservation laws, not conversation. Conservation laws have a deep connection with symmetries of nature, symmetries of space and time, and other types of symmetries play a central role in modern theories. Yeah, I'm taking the help of this making PPTs from my daughter-in-law. So she was doing it. Some typing mistakes will now and then come. Just ignore them. So this is the first part of slides, and we have even another one. So this is what we discussed yesterday. Are you able to see? Yeah, Rakesh. Rakesh. Akhil. Tarun. Akhil, are you able to see the screen?
Yes, sir.
Okay. This is what I explained you yesterday. Practical phase of physics. Astronomy, optical, spectroscopic, radio imaging techniques of physics are used in the field of astronomy. Geology, gravimetric, acoustic, nuclear, and mechanical methods are applied. All physics principles. Oceanography, meteorology, seismology. Seismology related to the prediction of earthquakes. Meteorology related to the prediction of weather, occurrence of cyclones, storms, oceanography, the various reserves in the oceans. All these things can be known with the help of sonar and other acoustic methods. Even radio imaging is adapted. And medical science, starting from thermometer, stethoscope, ECG, 2D echo, ultrasound, scanning, X-rays, everything, they are the products of physics. Yeah, we discussed it. Physics is a sequence of related ideas pursued, whose pursuit provides one with the cumulative effect of an higher vantage point and more encompassing view of the working with nature. So if you are ignorant of physics, then you are ignorant of your surroundings and nature. This point already we said, the fate of society is linked today completely with physics. So whatever you think and imagine. This also we said, pure physics, the complete basic laws and principles. Applied physics will talk about the applications in everyday life. These are all the aeroplanes, rockets, spacecrafts, artificial satellites. They're all based on the Newton's laws of motion, action, reaction, centripetal, centrifugal forces and all. Electric power, which is the backbone of modern industry. All industries need electric motors, huge motors. And the electric locomotives need electric power. In flights, electric power is needed. Even in satellites, solar panels generate the required electricity for them. So this is all about the electric power. Then radio and television, they are because of the microwaves. Even ham radio service is very useful nowadays, especially during cyclonic storms. They remove the power well in advance. Suppose if the cyclone is going to hit the coastal areas in another next 6 to 8 hours, then the power is completely removed to prevent all the electric shocks and all. In those cases, the ham radio will be used for communicating with the people who are staying there, and it is also used for communicating with the people who are working in the rescue operations. So televisions, of course, phones, everything, they are making use of the electromagnetic radiations, and lot of research was done by James Clerk Maxwell. Then nuclear energy, nuclear reactors, atom bomb, hydrogen bomb, etc. They make use of the concept of fission and fusion. And the basic principle is Einstein's idea of conservation of mass into energy. This also I quoted in the class other day. So Enrico Fermi was the man who used this conservation of mass and energy in designing the first ever nuclear reactor. And then we have the electronics. We have the electronics, computers. They also depend on the study of process of electron emission and the properties of semiconductors. You know, if a filament is made hot by connecting the filament to a 6.3 volts DC, then if you apply some negative voltage, then the filament will be emitting electrons, which can be accelerated in a particular direction to perform various tasks like rectification. See, we are able to convert AC to DC. The system, the phone, what you are using, they work on DC, whereas you are connecting it to AC source, AC plug. So there is a rectifier which converts that incoming AC into DC and makes your device to work. Then amplification. There is a mic in my computer. Whatever speech, whatever lecture I am giving, so its signal is amplified, increased. Then the modulator will be changing it into electromagnetic radiations. So through the hidden antenna, it escapes into the space. Then it is caught by your all the hand, maybe tabs or phones, whatever it is, because of the matching of unification of frequencies by the tuning process. I am giving you one meeting code and passcode. So what we are doing is you're all tuned to my frequency and you're able to hear my lecture. So this is called modulation. Once they reach your phone, the audio and video signals are separated. That's called demodulation. This is all complete electronics. And computers, they all make use of the properties of thermionic emission of electrons and semiconductors. So this is these are all the different things. Then I even referred about this different forces in nature: gravitational, electromagnetic, strong nuclear and weak nuclear forces. This is a comparison I made between the strong nuclear to gravitational force. So Fg, I'm moving from bottom to top. Fg to F electromagnetic to F weak nuclear interactions to F strong nuclear interactions. It is 1 is to 10 to the power of 2 is to 10 to the power of 9 is to 10 to the power of 38. I put it in reverse way. All the ranges up to what distance they act and between what particles they will be acting, and all details are given in this table. I'll be sharing it. And then unification of forces. This also I made a reference just now. Yeah, it's all about the unification theory. And the complete theory is shown in this block diagram. Then we have the another definition of science. Science is the adventure of the whole human race to learn, to live in, and perhaps to love the universe in which they are. But this basic theme of science is lost now. We are not loving universe. We are not loving our neighboring nature. We are throwing all the nonsense waste into our surroundings, garbage. Some of them are not degradable. The plastic bags, what you are using, they are non-degradable. So they are spoiling the earth's crust. So the very purpose of science is to live in and love the universe. Whereas now that very theme of science is lost because of the mad thinking of the human beings with over exploring attitude. To be a part of it, to understand it, you have to understand yourself to begin to feel that there is a capacity within man for far beyond that he felt he had. Like this is another definition. And science with certain historical understanding, certain philosophical understanding, social understanding, human understanding. So you need four things. You have to understand our history of the earth and universe. You have to have a philosophical understanding. You should have the social understanding, accommodative nature of not only your relatives or parents. You should have accommodative nature of your neighboring people and neighboring species of animals, plants, etc. That is missing nowadays. We are madly removing the forests. Deforestation is hectically going on. We are trying to occupy the whole earth. That is going to pose a great threat. The unpredicted monsoons, the unpredicted cyclonic storms, and other natural calamities are because we are not able to understand the nature. We are not able to understand our surroundings. We are not able to conserve the surroundings. And human understanding, that is also missing. The husband wife are not having proper understandings. They are fighting among themselves, and divorce has become a common feature nowadays. Next, the politicians are not having proper understanding to help in growth of the country. They are always fighting for themselves and their self-interest, and they are playing with the interest of the country. So this is all because of lack of human understanding. Whereas the philosophy of science needs, we need historical understanding, philosophical understanding, social understanding, and human understanding. I hope you people who are going to become the useful citizens of the country at least will evolve with understanding on all these five parameters. Then the conservation laws, this also I referred: law of conservation of mass, law of conservation of energy, law of conservation of linear momentum, law of conservation of angular momentum, law of conservation of charge. This is the last slide about invariance principle. It states that all the laws of nature remain unchanged for some particular change of physical condition. So invariance principles is due to some basic symmetry in nature. Conservation of linear momentum is due to homogeneity in space, but there are some limitations. There's a heterogeneity is there. So now and then means if the external forces are there, linear momentum is not conserved. For example, you are hitting the cricket ball with bat. So there, it's called inelastic collision. So linear momentum is conserved, but energy is not conserved. Like that, there are some exceptions. Conservation of angular momentum. Whenever if you are one among you is a good diver, jumping from the platforms into the swimming pool, making acrobatics, then you must and should conserve the angular momentum. A cat, while running from walls to the kitchen or kitchens to walls and jumping away from wall, even the cheetah in forest, tigers, etc., they conserve angular momentum. the angular momentum Earth is conserved always, and then conservation of energy. So this is all about the various conservation laws. Hence, a particular quantity will be invariant, means it won't change. I did little fast because already I explained them. Plus, in the forthcoming chapters, you're going to learn all these slides in detail. Hence, I did it little faster. So this is the last slide. So I'm just closing it. So now, so today we completed this very important chapter. We can say is the essence of your 2-year physics. I can say what all you are going to learn in these 2 years of plus 2 will be learned, will be just briefly was shown briefly in these PPTs or slides. So I'll try to give you in easier format because these PPTs cannot be uploaded directly to WhatsApp. I will try to convert it into script and send it to you by WhatsApp. We don't need much PPTs for the next mathematical physics and other chapters, only because it is a first topic. I have shown few slides in my first class. Now these are the summary. The PPTs will take care of the summary of the entire lesson. That is the physical world topic. So now with this, we concluded this topic, and I'll try to give you some paper next year, next week, with some simple questions which you can answer. I will relog in again. Please stay back to conclude this today's session. Please stay back. I'll log in back again.